The dataset that we use to perform this analysis to investigate spurious regression problem is called spurious. So let's open that dataset first. If you copy and paste the command lines from that PDF file online, you can see we open a data file is called spurious, and we clear the memory and the data in system. We also generate a variable called time. This is because in our database, we only have RW1 and RW2. Those are computer-generated variables. I don't have a time in that dataset, but we can generate a time index, and that basically equals to the number of the observation, so the sequence of the observation, and we set that variable time as the time index. So we have time series. If you submit these 3 lines, you will have RW1, RW2, and a time index is called time. Then we can run a regression model by using RW1 as the dependent variable and RW2 as the independent variable. That will give us this regression output. As demonstrated on my PowerPoint slide, the R-square is pretty decent. That's 70%. And you may notice that the correlation coefficient of RW2 is significant at 1% level. It looks like a good model. However, it has a problem. The tests there are actually not that reliable, because if we check the residual series for autocorrelation, so for example, we store the residual into a new variable called E hat, then we perform an LM test to check whether there's autocorrelation problems. You may notice that the p-values in these columns are all less than 1%, which means we rejected the no serial autocorrelation null hypothesis. There's some serious autocorrelation issue in this regression model. And we can also use TS line to examine the pattern of those 2 time series. As you can see from this diagram, those 2 lines actually are moving quite close to each other. And they move together over the time. It looks like there's a relationship. We can also use a command line that is called scatter. That's a command to generate scatter plot between 2 variables. So if you submit this line, scatter RW1, RW2, it will give you this scatter plot. And once again, it demonstrates a very strong upward trend, which means potentially there is a positive correlation between those 2 variables. But as a matter of fact, it's just a coincidence. I randomly generate those 2 variables. They have absolutely nothing to do with each other. So this is a result of a spurious regression model. They looked good. They look good. But the series, the residual series is usually highly correlated with autocorrelation problem, and the seemingly significant relationship is just a number. It doesn't have any meaning.